Hello, we are discussing about GATE 2015 ECE paper. A unity negative feedback system with open loop transfer function has given k by s into s plus 1 into s plus 3, and we need to calculate k, that is the value of gain at which root locus is crossing the imaginary axis, that is j omega axis. Generally the value of k or the poles at which the root locus is going to be crossing the imaginary axis can be known from Routh-Hurwitz criteria. Routh-Hurwitz criteria. But to know this analysis of Routh-Hurwitz criteria, what we require is characteristic equation. So characteristic equation is 1 plus gh is equal to 0, where 1 plus gh is denominator of closed loop transfer function. So first we need to calculate denominator of closed loop transfer function and make that to 0. So we know that one closed loop transfer function is equal to g by 1 plus gh. H is nothing but feedback factor. Since it is unity negative feedback, h of s will be treated as 1. So simply it is equal to g by 1 plus g. So if you substitute g value of k by s into s plus 1 into s plus 3, you will get the closed loop transfer function as k divided by s into s plus 1 into s plus 3 plus k. You will get this one, and this is denominator, and still if you multiply this one, you will get it as k divided by s cube plus 4s square plus 3s plus k. So denominator of closed loop transfer function is nothing but characteristic when it is equal to 0. So now write the characteristic equation is, for the given system, s power s cube plus 4s square plus 3s plus k is equal to 0. Now apply Hurwitz criteria. Okay, Hurwitz criteria is first highest power s power 3 s power 2. So this will be 1 4 and it is 3 k. Next s power 1 s power naught we are going to calculate. So we will go for Hurwitz criteria. 4 into 3 minus k, 12 minus k divided by 4, 12 minus k divided by 4, and this side it is 0. Next 12 minus k by 4 into k divided by this one itself, you will get it as k. And for stability purpose, for a stable system, requirement is all elements in first column should be positive. So all elements in the first column should be positive, then only the system is stable. Okay, so we will see, since they are not directly given as real numbers, they are function of k. So first we need to find out what is the value of k that is going to be giving positive and real number. So s naught row, from s naught row we see that when k is present and you must get positive, so k has to be greater than 0. So any positive value which is going to be greater than 0 is going to be satisfied s naught row with positive sign. Now if you are looking at s1th column, then it is 12 minus k by 4 should be greater than 0. So 12 minus k should be greater than 0 and 12 should be greater than k. So all values of k which are less than 12, okay, all values of k which are going to be less than 12 satisfies the stable system condition. So system will be stable for all values of k, less than 12, for all values of k which is less than 12. But exactly at k is equal to 12, system comes into limitedly stable or system becomes marginally stable, that is at the verge of instability, marginally stable, where at this point it crosses the j omega axis. Okay, now if you want to know the poles, okay, so the answer for this one is at k is equal to 12, system becomes marginally stable where closed loop poles crosses the j omega axis. j omega axis. So if you want to know the poles, okay, the answer is till this point only, k is equal to 12. But now we are going to see what are the poles. The pole location also you can find out. So you want to know the pole location, okay, then for k is equal to 12, s1 row becomes all zeros. So s1 row becomes all zeros. Whenever any row all the elements are zeros, then we have to take the auxiliary equation. Auxiliary equation is, okay, the equation with coefficients which related to the row above this all zeros row. So 4 and k is going to be coefficients of auxiliary equation. So this is 4s square and it will become k constant. Okay, so the auxiliary equation is 4s square plus k is nothing but 12. This you can write it as s square plus 3 is equal to 0, s square is equal to minus 3, and s is equal to plus or minus j root 3. So it is crossing the imaginary axis, okay, at plus j3 and at minus j3. So these are the values. It is sigma and it is j omega axis. So the answer for this question is 12. And if you want to know the pole location at which it is crossing the imaginary axis, at the time the value is plus or minus j root 3. Okay, thank you.